Swayam Prabha. Digital India. Educated India.
Dear learners, I am Dr. Renuka Mainde, Corporate Nutritionist, Academic Counselor in IGNOU for their MSc DFSM course. Learners, objectives of present module are: understand the methods of milk processing, explain the different types of milk products prepared by processing of milk. Let's begin. Milk is a valuable nutritious food that has a short shelf life and requires careful handling. Milk is highly perishable because it is an excellent medium for the growth of microorganisms, particularly bacterial pathogens that can cause spoilage and diseases in consumers. Milk processing allows the preservation of milk for days, weeks, or months and help to reduce foodborne illnesses. The usable life of milk can be extended for several days through techniques such as cooling or fermentation. Pasteurization is a heat treatment process that extends the usable life of milk and reduces the number of possible pathogenic microorganisms to a level at which they do not represent a significant health hazard. Milk can be processed further to convert it into high-value, concentrated and easily transportable dairy products with long shelf lives such as butter, cheese and ghee. Processing of milk. Processing of dairy products gives small-scale dairy producer higher cash incomes than selling raw milk and offer better opportunities to reach regional and urban markets. Milk processing can also help to deal with seasonal fluctuations in milk supply. The transformation of raw milk into processed milk and products can benefit entire communities by generating off-farm jobs in milk collection, transportation, processing and marketing. Let us understand types of processed milk varieties. Toned milk. Toned milk means the milk obtained by the addition of water and skim milk powder to whole milk. In practice, whole buffalo milk is admixed with reconstituted spray-dried skim milk for its production. Under PFA, that is Prevention of Food Adulteration Rules 1976, toned milk should contain a minimum of 3% fat and 8.5% solid non-fat throughout the country, whereas double-toned milk should contain a minimum of 1.5% fat and 9% solid non-fat throughout the India. Toned milk, the calculated amount of potable water is received in the pasteurizing vat or tank equipped with an agitator. The water is heated with the agitator is kept in motion to 38 to 43 degrees centigrade. Then a proportionate amount of spray-dried skim milk is slowly added at the point of agitation and the mixture thoroughly agitated till it dissolves completely. A calculated amount of whole buffalo milk is now added and the mixture again agitated thoroughly till a homogeneous mixture is obtained. The mixture is then filtered, pasteurized at 63 degrees centigrade for 30 minutes, rapidly cool to 5 degrees centigrade, packed and kept at 5 degrees centigrade or below until distribution. Let us understand what is standard milk. In this variety, milk fat and solid non-fat content has to be adjusted to a certain predetermined level. Standardization can be done by partially skimming the fat in the milk with a cream separator or by admixing with fresh or reconstituted skim milk in proper proportions. Under FSS Rules 2011, standardized milk for liquid consumption should contain a minimum of 4.5% fat and 8.5% SNF throughout the country. Standardized milk may be marketed as such or used for making certain milk products. Advantages of standard milk: ensures a milk of practically uniform and constant composition with good nutritive value to the consumers. The surplus fat can be converted into butter and ghee. Possible to reduce the cost of milk. More easily digestible because of reduced fat content. Disadvantages of standard milk: the initial reaction of the consumer may be that standardized milk is thinner than the whole milk. Flavored milk: adding delectable flavor and befitting color to milk makes it highly palatable and increases the sale of milk. When the term milk is used, the product should contain a milk fat content at least equal to minimum legal requirement for specific type of market milk. When the fat level is lower, that is 1 to 2%, the term dairy drink may be used. The purpose is to make milk more palatable to those who do not relish it as such, to stimulate the sale of milk, to put skim milk to profitable use. Let us understand types of flavored milk. The main types of flavored milk are chocolate milk, fruit flavored milk, and sterilized flavor milk. In chocolate milk, the following formula may be used: cocoa powder 1 to 1.5%, sugar 7 to 9%, stabilizer 0.2%, sodium alginate can be used, fat level, milk legal standard of milk. Fat level as per the legal standards of milk. Let us understand what is fruit flavored milk. Permitted fruit flavors, essence together with permitted colors and sugar are used. The method of preparation is similar to that used for chocolate milk or drink. The common flavor used are strawberry, orange, lemon, pineapple, banana, vanilla, etc. Pure fruit juices, syrups can be satisfactorily combined with milk to form milkshakes. To obtain good result, the following precautions should be taken. No citric acid or tartaric acid should be added to the fruit syrup, as this may cause curdling. The pH of the milk syrup mixture should be about 5, which is safe from the curdling point of view. Excessively sweet syrups should be avoided. The best sugar content of syrup is 45 to 55%. 1 part of fruit syrup is added to 5 parts of milk. The fruits which gives good result are strawberry, oranges, pineapple, blackberry, raspberry and blackcurrant. Care should be taken to see that there is a pleasant blend of sweet fruit and milk flavor. Let us understand what is reconstituted milk. Reconstituted milk may be prepared either from skim milk powder or whole milk powder by the addition of water. The composition, especially fat, solid non-fat ratio, is adjusted equal to that of fresh skim milk or fresh whole milk. Whole milk powder possesses a problem in reconstitution because of poor wettability. Therefore, reconstitution should be done with care. The temperature of water should be between 40 to 45 degrees centigrade. After reconstitution, it should be held for sufficient time, preferably for 1 hour, for proper hydration of powder particles. For greater convenience, instant powder in which wettability is increased by agglomeration may be used. When skim milk powder is to be used after reconstitution for extending the fluid milk supply, in preparing recombined or toned milk, low heat skim milk powder should be the choice. Reconstitution equipment involve the use of high-speed agitators creating a vortex or venturi type mixer or pump to speed up dispersion and solution of powder. Preparation of whole milk from whole milk powder after reconstitution is not as common as reconstituted skim milk because of certain special problem. Whole milk powder has poor wettability due to the presence of fat which is hygroscopic to water. The shelf life of whole milk powder is also limited. Let us understand advantages of reconstituted milk. It helps in making up the shortage of fresh milk supplies in developing countries. It is useful for the armed forces posted at far off places that are difficult to reach. Recombined milk. This refers to the product obtained when butter oil, also called as anhydrous milk fat, skim milk powder and water are combined in the correct proportions to yield fluid milk. Fat may also be obtained from other sources such as unsalted butter or plastic cream. The acceptability of recombined milk is influenced by the quality of anhydrous milk fat. Recombined milk serves as a means of supplying fluid milk in non-dairy areas. The recombining process offers several advantages. It reduces transport cost, eliminates refrigeration and lowers packaging cost besides helping in the development of local industries. The main market for recombined milk and milk product is in developing countries where they make up for the milk shortage and also find increasing utilization in emerging situations. Let's begin with pasteurization of milk. Pasteurization is a process named after scientist Louis Pasteur that applies heat to destroy pathogen in foods. For dairy industry, the term pasteurization, pasteurized and similar term means the process of heating every particle of milk or milk product in properly designed and operated equipment. Pasteurization is a key process in modern dairy plant operations and also forms an integral part of manufacturing of various indigenous and western dairy products. Milk is a perfect medium for growth of microorganisms and growth of pathogenic organism can cause diseases such as tuberculosis. Pasteurization kills the organisms responsible for spread of diseases through milk and makes it safe for consumption. In general terms, it is heating milk or its product to such temperature which destroys nearly all microorganisms present in it without affecting the composition or properties of the product. Definition of pasteurization of milk. As per the definition of International Dairy Federation, pasteurization is a process applied to a product with an objective of minimizing possible health hazard arising from pathogenic microorganisms associated with milk by heat treatment, which is consistent with minimal chemical, physical and organoleptic changes in the product. The heat treatment suggested by the IDF for pasteurization of milk are 15 seconds at 71.7 degrees centigrade or 30 minutes at 62.8 degrees centigrade can be regarded as universal reference treatments. The three aspects emerging from the definition are level and degree of heat treatment, minimum chemical, physical and organoleptic changes and minimum health hazard. Let us understand different methods used in milk pasteurization. High temperature short time is the most widely used method across the globe. High temperature short time pasteurization. This type of pasteurization is also known as flash pasteurization. Flash pasteurization involves heating milk to 71.7 degrees centigrade for 15 seconds to kill Coxella burnetii, which is the most heat resistant pathogen in raw milk. It is technically impossible to bring milk to that exact temperature. Hence, it is always safe to work with range of temperatures. Milk can be heated to temperature between 72 degree to 74 degree centigrade for 15 to 20 seconds. This will ensure that milk is heated uniformly to the required temperature. This method is most suitable in continuous pasteurization system. Flash pasteurized milk will keep for between 16 and 21 days. For commercial reasons, some manufacturers intentionally reduce the number of days to push the product out of the shelves. Let us understand the components of high temperature short time pasteurization plant. The complete pasteurizer plant consists of constant head tank, milk feed pump, flow controller, filters, clarifiers, homogenizers, plate heat exchanger consisting of bank of plates compartmentalized into regeneration, heating, holding and cooling section, flow diversion valve, instrument associated with indicating controlling or recorded function, systems for providing steam, air, water, heating and cooling arrangements, piping systems to link various components. Let us understand functions of specific parts. Float controlled balance tank maintains a constant head of the milk for feeding raw milk pump. Also receives milk diverted by flow diversion valve. Pump, either a rotary positive pump between the regeneration and heating section or a centrifugal pump with flow control device to ensure constant output after float controlled balance tank is used. Plates. The plate heat exchanger, also called paraflow, is commonly used in the high temperature short time system. The plate heat exchanger is a compact, easily cleaned unit. Its plates may be used for heating, cooling and regeneration. These plates are supported in a press between a terminal block in each heating or cooling sections. The heat moves from a hot to cold medium through stainless steel plates. A space approximately 3 mm is maintained between the plates by a non-absorbent rubber gasket or seal which can be vulcanized to them. The plates are numbered and must be properly assembled. They are tightened into place and designed to provide a uniform but somewhat turbulent flow for rapid heat transfer. Raised sections on the plates in the form of knobs, diamonds and channels help provide the turbulent action. Greater capacity is secured by adding more plates. Ports are provided in appropriate places both at the top and bottom of the plates to permit the product and the heating cooling medium to flow without mixing. Filter. Filter units are connected directly to the high temperature short time system placed after the preheater or regenerative section. These units using 40 to 90 nylon mesh cloth are usually cylindrical in shape. Usually, 2 filters are attached. When one is being used, other can be subjected to cleaning. This permits continuous operation. Regeneration. The raw chilled incoming milk is partially and indirectly heated by the heated outgoing milk. This adds to the economy of the high temperature short time process as the incoming milk requires less heating by hot water to raise its temperature to pasteurization temperature in the heating section. Heating. The preheated milk from regeneration section passes through heating section of high temperature short time where it is heated to 72 degrees centigrade or more with the help of hot water from hot well. Thereafter, the heated milk enters into the holding section. Holding. The holding tube ensures that the milk is held for a specified time not less than 15 seconds at the pasteurization temperature of 72 degrees centigrade or more. Flow diversion valve. This routes the milk after holding section. If the milk is properly pasteurized, it flows forward through the unit. In case milk is not heated to the set heating temperature, it is automatically diverted by the flow diversion valve back to the float controlled balance tank for reprocessing. It is usually operated by air pressure working against a strong spring. If the temperature of heated milk falls below the set temperature, air pressure is released and the valve snaps shut immediately. When the temperature is regained, air pressure builds up and the valve opens up for the forward flow to occur. The system is so arranged that any failure of electricity moves the valve in the diverted position. regeneration. The pasteurized hot outgoing milk is partially and indirectly cooled by the incoming cold milk. This again adds to the economy of the high temperature short time process. In fact, when pre-cooled raw milk is received, regeneration efficiency is 90% and above, which obviates cooling using well water together. Control panel contains instruments, controls, flow diversion valve mechanism and holding system, all centralized in one moisture-proof panel. The lower half of the panel forms an air-insulated chamber which carries the holding tube. Automatic control device. This include steam pressure controller, water temperature controller and milk temperature recorder. Steam pressure controller maintains a constant hot water temperature for heating milk accurately to the required pasteurization temperature. It acts as a reducing valve in the steam supply line to give a constant steam pressure. Water temperature controller regulates the amount of steam entering the hot water circulating system. Milk temperature recorder records the temperature of milk leaving the holding tube or plate. This is an electric contact instrument that operates either a flow diversion valve or a milk pump, automatically preventing milk from leaving the holding section at temperatures below the onset in the control panel. Both the frequency and duration of the flow diversion and the temperature of milk leaving the heating section are recorded in the thermograph by means of two different colored pens. Hot water circulates hot water through the heating section of the machine to maintain the correct heating temperature within very fine limits. Testing of holding time. The holding time is calculated between the points at which heated milk leaves the heating section and reaches the flow diversion valve. The efficiency of pasteurization in the high temperature short time system depends on attaining the requisite temperature along with the desired holding time. Hence, latter should be checked periodically. Several methods are used for determining the holding time. Example, electrical conductivity method, the dye injection method, the electronic timer method, etc. The requirements for heat treatment and modification which can occur in milk, time temperature profiles have been established for heat treatment process. Devices for controlling the heat treatment process. Automatic temperature control and recording devices. Automatic safety device to avoid insufficient heating of the milk with the recording device for time and temperature and valve position for the flow as well as passage and recirculation of the milk or cleaning. Safety device with automatic recording against unplanned blending of pasteurized or sterilized milk with non-heated milk based on pressure increase after heating or holding section of the heat exchanger. The most widely used installation for heat treatment of milk is plate heat exchanger. For reason related the flow condition, tubular heat exchangers are used when operating at temperature level more than 100 degrees centigrade. Let us understand next method, low temperature long time pasteurization. Here, the temperature used for pasteurization are reduced to 63 degrees centigrade and held for 30 minutes. The prolonged holding period alters the structure of the milk protein, making them better suited for making yogurt. This method is best for batch pasteurization, where the milk is held in jacketed vat for effective pasteurization. There are many designs of batch pasteurizers in the market that are suitable for both domestic and commercial use. Ultra high temperature pasteurization. This is completely closed pasteurization method. The product is never exposed even for a fraction of a second during the entire process. It involves heating milk or cream to between 135 degrees centigrade to 150 degrees centigrade for 1 to 2 seconds, then chilling it immediately and aseptically packaging it in a airtight container for storage. Despite the risk of Maillard browning, ultra-high temperature pasteurization remains the most popular milk preservation method for safe and stable milk. Let us understand steps in pasteurization of milk. Milk chilling. Chilling is not pasteurization process, but it is a necessary step when dealing with large volume of milk. Milk leaves the cow's udder at a temperature above the ambient, which encourages rapid bacterial multiplication that speeds up spoilage. However, reducing the temperature to between 2 degrees centigrade to 5 degrees centigrade arrests bacterial growth and metabolism. This provides a head start at keeping the quality before proper pasteurization commences. Preheating, regeneration and standardization stage. After bulking, the chilled milk is heated to about 40 degrees centigrade to facilitate easy separation of butterfat during standardization. The system uses regenerative heating. It uses the heat of the already pasteurized milk to heat up the incoming chilled milk. The chilled milk in a counter current flow cools down the pasteurized milk. The purpose of standardization is to obtain a product with uniform content of butterfat. Clarification stage. Clarification is essential for removing all foreign matter from the product. Large solid particles are removed by straining the milk through tubular metallic filters. A centrifugal clarifier is used to remove all soil and sediments from milk. The filter, usually fitted in parallel twins, permit continuous processing as one can be cleaned while other is running. The filters are cleaned regularly to avoid the growth of bacteria. Standardization stage. It is important to standardize milk fat to ensure a product of consistent quality in the market. Different consumers prefer different products. There are consumers who will consume skim milk only, while others are those who will take low-fat milk. There are those who will take standardized milk, while there are those who prefer high-fat milk. Standardization is necessary to ensure that all the customers are catered for. It is during the process of standardization that the butterfat that is separated and is used for making cream and other fat-based products such as butter and ghee. Let us understand homogenization stage. Homogenization is a physical process of breaking down the milk fat globules into tiny droplets to discourage cream separation. Tiny droplets of fat do not rise in a milk column since reducing their size also increases their density in the milk. A milk homogenizer working at between 100 to 170 bar splits all the fat globules into very tiny droplets that increase the level of integration of the fat in the milk. As a result, milk fat remains uniformly distributed in the milk. Heating section utilizes heat from steam to raise temperature of milk from about 60 degrees centigrade to the required 72 degrees centigrade that is effective to kill the Clostridium botulinum spores. The steam exchanger heat with the milk across the plate heat exchanger plates in a counter current motion. In the end, if the section there is a temperature sensor which controls the flow diversion valve. Any milk that does not attain the required temperature is diverted back to the heating section until it attains the required temperature. Holding section. After heating, milk flows into the holding tubes whose lengths have been calibrated with the milk flow rate to ensure that milk take at least 16 seconds in the tubes. All the milk must maintain the required pasteurization temperature at the end of the tubes. In case of a breach, a sensor will trigger the flow diversion valve to take the milk back to the heating section to bring the milk to the required temperature. Once the milk has attained the required temperatures at the end of the holding tubes, milk flows back to the regeneration section to heat the incoming chilled milk while in itself being cooled down to about 30 degrees centigrade. Cooling section. After regenerative cooling of pasteurized milk, it moves to cooling section of the plate heat exchanger where chilled water coolant lowers the temperature of pasteurized milk to 4 degrees centigrade. The chilled milk is then pumped to the packaging machines for aseptic packaging and subsequent storage in the cold room. Significance of pasteurization. Proper pasteurization is necessary for the following reason. The chief objective of milk pasteurization is to destroy pathogenic bacteria that could have a public health concern. By destroying this microorganism, the product becomes safe for public consumption. Secondly, pasteurization eliminates destructive bacteria and enzymes that could cause spoilage of the product. This leads to prolonged shelf life of the milk. There is a need to ensure that the product can keep for longer periods without expensive storage equipment. Pasteurization will eliminate spoilage bacteria and enzymes and extend the shelf life of the product. Learners, let us understand what is homogenization. Homogenization implies mechanical treatment to break fat globules into smaller size of 2 micromoles or less and uniformly disperse them in milk. Homogenization in the dairy industry is used principally to prevent or delay the formation of a cream layer in full cream milk by reducing the diameter of the fat globules. After homogenization, the size of fat globules becomes less than 2 micromoles. The average size of milk fat globules in milk is 2 to 12 micromoles. The number of fat globules is 3 to 4 billions in a milliliter of milk. In the past, pasteurized milk usually was not homogenized, although the flavor of the milk becomes fuller by homogenization. A certain amount of cream was permitted to form to show the consumer clearly the full cream character of milk. Sterilized milk, evaporated or condensed milk and cream are generally homogenized. Let us understand the definition of homogenization of milk. Homogenization can be defined as the process in which fat globules in milk are broken down to a size small enough to prevent the formation of cream layer. Homogenizer is a machine which disintegrates fat globules of milk. The number of fat globules in homogenized milk is about 10,000 times greater than those in unhomogenized milk. The size of fat globule is reduced to less than 1 micron, while normal fat globule size averages to 2 to 12 microns in the milk. The number of fat globules will be increased, but total volume of fat globules will remain almost same. The surface area of newly formed smaller fast globules is increased by 4 to 6 folds. Merits of homogenization: no formation of cream layer, fat will not churn, thick body and rich appearance, produces soft curd, easily digestible, less susceptibility to oxidation. Demerits: increased cost of production, fat from returned homogenized milk is difficult to salvage, sediment is greater, may produce rancidity if temperature is not kept adequately high. Let us understand what is homogenizer. The homogenizer consists of a high pressure reciprocating pump driven by a powerful motor and a black pressure device, that is homogenizer head. It is equipped with a set of valves and valve pressure screws that enable the exposure of liquid products to a very high pressures. To withstand the high pressure and velocity and to prevent the wearing of the head, special metal alloy satellite, which is noted for its hardness, is used for making the homogenizer valve. The power source is an electric motor built into the unit. The motor drives the crank and piston assembly either by a pulley or by a set of gears, both of which greatly reduce RPM, that is rotation per minute, to provide a suitable speed for the piston. The gears, cranks and drive shafts run in an oil bath. The piston are usually straight rod, gives a small displacement. The piston extends from the crankshaft in the crank housing into the pressure chamber in the homogenizer head. Each piston passes through a packaging gland especially designed both to prevent product leakage despite high operating pressures and to facilitate sanitation. The parts of homogenizer head are precisely ground and made fit together in correct position in order to avoid any leak. The wear and tear of homogenizer head is also frequently checked because if there is any shell gap, the fat globules may escape through it and lower the efficiency of homogenization. Homogenizer process. The high velocity of milk confers high kinetic energy. The energy is dissipated into heat, and since the passage time through the slit is small, the average energy density is very high. Such high energy densities lead to very intense turbulence. The pressure fluctuations are not desirable when the flow velocity in the valve slit is at its maximum. Local pressure is less than zero. A negative pressure may cause cavitations. Homogenizer. The collapsing process creates huge shock waves which may disrupt particles. The degree to which this happens in homogenizer varies. In most cases, globule disruption primarily is caused by turbulence. The small globules do not rise to the top of milk but remain suspended in the milk or rise very slowly. Immediately after the globules are broken down, they show a tendency to cluster and rise to the top of the milk. Two-stage homogenization prevents this. The second stage breaks up any cluster, thus ensuring better dispersion on the fat throughout the milk. Types of homogenizer. High pressure homogenizer. This type of homogenizer consists of single acting triplex pump with each cylinder having suction and discharge valves. The discharge valve of each pump empties into common discharge pipe in which a special valve is placed. The pressure ranges between 35 to 350 bar depending on type of construction of the valve. Low pressure rotary type homogenizer. Usually operating pressures are below 35 bar. The construction is so designed that milk is subjected to grinding and shearing action. Sonic vibrator. Milk is subjected to high frequency vibration in a device called sonic vibrator or oscillator. The machine consists of a flat disc actuated by an electric magnet located over an anvil containing a hole through which milk enters. The milk passes through the space between the disc and an anvil, and the vibrating action of the disc against the film of making hammers the fluid at high frequency. Let us understand the details of homogenizer. Homogenizer can be single stage, double stage or even multi-stage type. A single stage homogenizer are equipped with only one homogenizing valve. A homogenizing valve usually consists of a valve, valve seat and an impact ring. These are held with a valve body. On the other hand, double stage homogenizer are equipped with an additional homogenizing valve. Commercial milk homogenizer are high pressure reciprocating pumps, each having a sanitary head upon which is mounted homogenizing valve. Homogenizer having 3, 5 or 7 piston driven by a shaft through connecting rods and cross heads. The pump head containing section manifold with passage connecting to the individual cylinders. Each cylinder has suction and a discharge valves, either poppet or ball type. A valve are the spring loaded in some model. The homogenizing valve accomplished its intended function by restructuring the product flow area, which results in the pressure commonly known as homogenizing pressure. The degree of homogenizing effect can be controlled by regulating this pressure or corrected by restriction to the flow. A pressure gauge is used to indicate the pressure. Generally, double stage homogenizers are used and the pressure of 140 bar and 35 bar in the first and second stage respectively are maintained. Let us understand effect of homogenization on physical chemical properties of milk. Reduction of fat globule size. Reduction of fat globule size to less than 2 micromoles prevents the formation of cream layer and increases the surface area of the fat about 6 times. Whiter milk. Homogenization of milk increases its whitening power due to an increase in the number and surface area of fat globules. Adsorption of casein, micelles and serum protein on newly created fat globule surfaces increases scattering of light, thereby causing whiter appearance. Physiology of nutrition. Homogenization has been reported to improve the digestibility of milk due to increase in the number and surface area of the fat globules. Flavor of milk. Homogenized milk has a uniform flavor throughout. It tastes richer, smoother and creamier than unhomogenized milk due to an increase in surface area of the fat globules, which are uniformly distributed in milk. Sensitivity to lipase. Unhomogenized milk is more susceptible to enzymic activities, especially lipase action, than unhomogenized milk. Lipase can cause rancidity rapidly in homogenized raw milk. Susceptibility to oxidation. Homogenized milk is more susceptible to oxidize flavors caused by natural or artificial light than unhomogenized milk. To prevent development of flavors, homogenized milk must be packed in opaque containers such as cartons, plastic containers or colored bottles. Sediment on storage. Homogenized milk may develop dark sediment at the bottom of the container after standing for 24 hours. This is due to settling of cells, foreign matter and casein particles. To prevent sediment formation, homogenized milk must be filtered or clarified, preferably before homogenization. Bacterial count. There will be an apparent increase in bacterial count after homogenization due to the breakup of clumps and colonies of organism. Let us understand ultra high temperature process. It is a modern technique for milk sterilization. Long life or ultra high temperature milk originated at Switzerland in 1961. It has long storage life and greater consumer acceptability than the conventional canned sterilized milk, in which the product suffers greater alteration in flavor, color and nutritional quality. While ultra high temperature processing is a one way of producing sterilized milk, it is predated in terms of development and commercial application in container sterilization methods, which also produce long life products. In container sterilization process, in which milk is sterilized in either glass or high density polyethylene bottles, operate at lower temperature than ultra high temperature processes, but for longer times. The process requires minimum sterilization temperature of 100 degrees centigrade for sufficient time to ensure that product passes the turbidity test. The test is based on the confirmation of adequate heat treatment by the use of ammonium sulfate to precipitate milk proteins, including heat denatured whey proteins. In container, sterilization may be achieved either by batch processing, in which bottles of milk are heat treated in autoclaves or by continuous processing where bottles of milk pass through sterilizer. Two methods of continuous processing are common: the vertical tower or hydrostatic sterilizer and horizontal sterilizers. Advantages of ultra high temperature. Ultra high temperature treated milk has definite advantage when the distance between the producer and the consumer is wide. Ultra high temperature treated milk can be kept for several months without refrigeration and advantageous in warm summers. Temporary surpluses due to seasonal variation can be covered by subjecting milk to ultra high temperature treatment. Manpower costs are saved. Milk can be stored at home at all the time. It can be readily available at distant location and at all odd hours. Disadvantages of ultra high temperature. Flavor of ultra high temperature milk is dissimilar to pasteurized milk. Chances of formation of deposit within the system, particularly in the direct steam system, which causes extra operating cost. Age, gelation during the storage, higher cost of aseptic packaging, sometimes fat separation and sedimentation of insoluble particles may occur during storage. Nutritive value is much diminished as compared to pasteurized milk. It is expensive. Packaging of milk. Packaging may be defined as a Packaging of milk. Packaging may be defined as a means for protection and prolongation of shelf life of a particular food item so that it may be transported without any hassle. Packaging serves the following purpose: to contain and protect. I'll just repeat this again. Packaging of milk. Packaging may be defined as a means for protection and prolongation of shelf life of a particular food item so that it may be transported without any hassle. Packaging serves the following purpose: to protect the product during handling and storage, thereby increasing shelf life, to inform consumer about product quality and facilitate transportation, to attract the attention of consumer and increase the sale, to prevent the scope of adulteration. The name, trade name, description of food contained in the package and business address of the manufacturers are printed on the package. A statement about the addition of preservative and its class, permitted coloring agent, antioxidants, vitamins, anti-caking agent, stabilizing agent, emulsifying agent, minerals, chemical composition of product and the amount of energy supplied by the product, the net weight or the number or the volume of content, batch number, code number are also mentioned on the package. Different packaging material. Common packaging materials for market milk industry are glass, plastic, co-extruded and multi-layer packaging material. Glass. Earlier, market milk was distributed in glass bottle. These bottles could be reused after adequate cleaning in a mechanized bottle washing machines. Glasses are generally of two types: transparent and opaque. Glass does not react chemically with the product contained in it. It has excellent barrier property. Besides this, transparent bottle provides clear visibility of the product inside it, but glasses are brittle in nature, prone to breakage during transportation, handling, and even mechanized cleaning. Moreover, they are heavier than plastic and paper packs. Sterilized flavored milk drinks are still being packed in heat-resistant glass bottles in India. Presently, flexible polymeric containers have replaced glass bottles for packaging of milk. Plastics, the most popular material for packing of market milk. Plastic packaging material included low density polyethylene, linear low density polyethylene, high density polyethylene, high molecular high density polyethylene. These are flexible in nature and are mostly used as wrapper or sachets, bag or pouches. It protects the food from microorganisms, insects, etc. It controls humidity of the dairy product. Let's conclude, learners. Milk is a valuable nutritious food that has short shelf life and requires careful handling. Milk is a highly perishable because it is an excellent medium for the growth of microorganisms, particularly bacterial pathogens that can cause spoilage and disease in consumers. Milk processing allows the preservation of milk for days, weeks or months and helps to reduce foodborne illnesses. Pasteurization is a process applied to a product with an objective of minimizing possible health hazard arising from pathogenic microorganisms associated with milk by heat treatment, which is consistent with minimal chemical, physical and organoleptic changes in the product. High temperature, short time pasteurization, most method used for pasteurization of milk. Low temperature, long time pasteurization and ultra high temperature pasteurization are also used methods for pasteurization. Homogenization can be defined as a process in which fat globules in the milk are broken down to a size small enough to prevent the formation of cream layer. Homogenizer is a machine which disintegrates fat globules of milk. The homogenizer consists of a high pressure reciprocating pump driven by a powerful motor and a back pressure device, that is homogenizer head. It is equipped with a set of valves, valve pressure screw that enable the exposure of liquid products to very high pressure. Ultra high temperature process is a modern technique for milk sterilization. Long life or ultra high temperature milk originated at Switzerland in 1961. It has long storage life and greater consumer acceptability than the conventional canned sterilized milk, in which product suffers greater alteration in flavor, color and nutritional quality. Earlier, market milk was distributed in glass bottles. The bottles could be reused after adequate in mechanized bottle washing machines. The most popular material for packaging of market milk, plastic packaging material that include low density polyethylene, linear low density polyethylene, high density polyethylene. Learners, in the next part, we shall be learning on overview on milk market and different milk and milk products. Thank you.